Now, let's do a deep dive on a specific BA's performance in trading. You can also look at the US electric system as a whole. That's what the detailed data pane is all about. For this demo, I've selected PJM, one of the largest balancing authorities. PJM is generally located in the Mid-Atlantic and Appalachia. You can select your region of interest from the Status Map tab or use this selection tool here. This pop-up is handy because it reminds you of geographical location. Or if you know what you're looking for, you can switch to List View. You can select multiple regions or balancing authorities to compare them to. But for now, let's just go with PJM. Now, before we get all geeky with the data, let me quickly show you these other selection tools. This sub-tab lets you toggle between looking at graphical representations and the source data itself. You can break the data down by various time periods to look at larger trends beyond hourly information. As before, your date selector is here. This curve analyzer option is very useful to energy experts, but can be a little mysterious to the uninitiated. When you select it, the site computes the highest demand from the last 7 days. It then plots all the demand values as a percentage against this peak demand. It's a way to show the volatility of electricity requirements. If this demand went unanswered, brownouts, rolling blackouts, or even equipment damage could occur. First up is the demand graph. Note the cyclical nature of power demand. It displays a fairly recognizable pattern throughout the day. During summer months, demand for electricity swells in the evening hours and is at its lowest in the early morning. The dotted line shows the 24-hour forecast for the day. The blue solid line, the current demand. For more detail, use the zoom control here. A given BA's forecast error is shown in this graph. Accurate forecasts are key for the efficiency and stability of the grid because not all generating plants can respond to unexpected demand equally. Remember how BAs trade electricity with their neighboring systems to meet demand? The next two visuals explain what's happening. First, this plot shows whether your selected BA imported power to meet its own demand or exported surplus power to its trading partners. We call that inflow and outflow. The next graph breaks out that electricity flow to each partner. For this balancing authority, we can see that the majority of outflow went from PJM to MISO, or from the Pennsylvania-Ohio region to further points west in Wisconsin and Illinois. I know where those BAs are because I flipped back to the map to remind me. Returning to our data pane, we see what's called interchange error. Balancing authorities don't always report the same electricity they send to or receive from each other. When this happens between the two trading partners, we plot the difference between the reported values here. And we're not trying to out anyone here. This tool is silent as to the reason of the disagreement or what the true value is. Our goal is to give system operators, government officials, and other interested parties information they need to make the grid more efficient and reliable.